What's up, CoderByte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today we are going to be continuing to talk all about linked lists. Today's problem is what I would call medium difficulty problem. As far as linked list problems go, we're going to be using the algorithm we learned last time, reversing nodes of a linked list, and applying it to a slightly harder problem. With that, let's get into this week's problem. Okay, so last week we went over all about reversing the nodes of a linked list. And this is a pretty basic algorithm, but it's going to be the underlying algorithm to solve this week's problem, which is slightly different, slightly harder, but ultimately going to be very similar. So let's go over reversing a linked list. Often a problem calls for reversing the nodes of a linked list in place. This algorithm is an efficient way to solve that problem. So whether or not the problem is calling out, please reverse the nodes of this linked list, or we have to reverse some of the nodes in some pattern according to the problem, or it doesn't even say reverse the nodes, but we would have to do that. We would have to figure out that we would have to do that. This is often the underlying algorithm, this reversal of the nodes of a linked list. So what's this week's problem? Given the head of a linked list and a number k, reverse every alternating k-sized sublist starting from the head. If in the end you're left with a sublist with less than k elements, reverse that too. So what does that even mean? Let's look at an example. So here we have an example. The top is before we've done anything to it, and we have the nodes 1, 2, 3, 4, 5, 6, 7, and 8, and this is a linked list. The head is at 1. Our k is 2, so that means that our sublist size are going to be 2 nodes long. And basically what we have to do is we have to start from the head and we have to reverse sublists of size k. So our first sublist of size k will be 1 and 2. So we reverse those, we get 2 and 1, and we reconnect it to our main linked list. Then alternating, we want to skip over the next sublist of size 2. So that will be 3 and 4, skip those, don't reverse those. Then alternating again, we have another sublist of size 2, that's 5 and 6 here, so we reverse those, we get 6 and 5, and reconnect it to our linked list. And finally, we have 7 and 8, which we leave as is. So that's the problem. It's not much harder than last week's because at the end of the day, we're just reversing nodes in a linked list. The hard pieces here are going to be keeping track of those alternating sublists and being able to reconnect the reversed sublists back to our parent linked list in the right order where they're meant to be. So what's our approach here? How are we going to solve this problem? The first thing we're going to do is we're just going to loop through the linked list. Next, we will reverse k elements. This will be using last week's algorithm. The difference being that we will keep track of the last node of the previous part of the linked list. So this will be before we began reversing elements. And this is going to be so we can reconnect that sublist back, because you can imagine that the last node of the previous part of the linked list now needs its next to point to the new head of the reversed sublist, if that makes sense. Hopefully with a visualization it will really make sense. So we have to keep track of that. And the other thing we have to keep track of is the last node of the sublist after we've reversed it, because we have to have that node's next point to the next node in the parent linked list to kind of put it back in its place before we took it out, reversed it, put it back. So those are kind of differences so far between last week's algorithm and this week's algorithm. After that, we reconnect the reversed section of the list by setting the last node of the previous part of the linked lists dot next, that's a mouthful, to the last node processed in the reversal, which will be the head of the sublist. So if we look at our previous slide here, let's say we just looked at 5 and 6, we just reversed them. Our last node of the last part would be 4, which we would then attach to our new head of our reversed sublist. And then our next node will be 7, which we'll have to point our 5, which is the tail of our reversed sublist. We will have to point 5 at 7. So that's why we have to keep track of those things. Okay, so let's go back to where we were. Reconnect the last node of the sublist to the next node in the chain, as I just said. And finally, loop over the next k elements without reversing and repeat from step 1. So again, this is really just the same algorithm as last week with these kind of key little differences to help us keep track of where we are in the parent linked list after we reverse each sublist. So let's watch a visualization to kind of help explain all this English. So here we have our k equals 2, and we have our linked list starting at 1 with 1, 2, 3, 4, 5, 6, 7, and 8. And we have our last node of previous part, which starts at null because there is no last node that we've processed already. And what we do basically is we loop k times over our nodes. So that's how we get our 1 and our 2. We take these two nodes and we reverse them according to last week's algorithm. If you haven't seen last week's video, highly suggest you check it out. Reverse. And then we finally get our last node of our sublist, which is 1. This will be the last node processed after the reversal. And we set its .next to 3, which will be the next node that we would have processed if we were just going through this linked list from the beginning. We continue on for our alternating sublist of size k, which is 2, which we're not going to reverse. So then we process 3, we move on. We process 4, we move on. Now, we're finally back to reversing again, but we need to capture 4 somehow as our last node of previous part because we are going to have to point it to the new head of our reversed sublist. So let's change that. Our last node of our previous part is now set to 4, and now we're going to deal with 5 and 6 here. So we reverse 5 and 6, again, according to last week's algorithm. And then after we reverse those, we capture our last node of our sublist, which is now going to be equal to 5. So we update the last node of sublist equal to 5, and we connect the nodes. We take our last node of the previous part, which is 4. We set its .next to 6, and we do the same with 5, our last node of our sublist, and we set its .next equal to our whatever was going to be the next element in the chain. And that's the entire algorithm. So I think this will become even clearer in code. But, go over this a few times, make sure you're really understanding kind of conceptually what we're doing. And then let's jump into the code, and it should be relatively straightforward. Let's code this out. Okay, I am in Visual Studio Code with a totally blank file. And just like last week, I'm just going to quickly define a node class that we can use to represent our nodes in our linked list. So I'm going to start just by defining a class called node, and it's going to get a constructor, and the constructor is going to take a value and a next, and if we don't pass a next, we're going to set next equal to null, and then we're going to set this dot value equal to value and this dot next equal to next, and call it a day. The next thing I'm going to do is just define a convenience method called printlist, which is going to just loop through and print our linked list. So we're going to set temp equal to this because that will be, this represents the node that it's being called on. And basically, while temp exists, we are going to continue to move temp to be the dot next of whatever node we're at until we get to a dot next of null. So temp will be null, and we'll know we've reached the end of our list. So this is where we are going to say temp equal temp dot next, and then we can console.log temp. And I think that should be it for our print list. That should just work. And now finally, let's define our actual linked list just like we had in the slides. So I'm going to say const head is a new node 1. And then I'm just going to copy and paste this from where I have this prepped, because I don't need to write all that in front of you. But basically, this is just defining our linked list. We're setting each of our next properties based on where based on the head equal to each of these nodes. And just, so everybody understands, we could have defined our nodes, individually and then passed in as our next over here. Like this could have been, node 3, and then our node 2 would have node 3 as its next node, but this is another way of doing it, and it works just as well, so who cares? And then finally, let's say head.printlist, and let's just see what we get here. Okay, so instead of printing all of those, I'm going to just print the values. And let's see what we get here. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So that's what we want. Okay, so now let's define our function. This is going to be our main function to solve our problem that we have for today. So here we have reverse alternate sublists, reverse alternate k nodes. And I think what we want to do is we want to pass in a head and a k. And then let's down here do reverse alternate nodes, and let's pass in our head and our k of 2. And basically what we want to do is capture this in a variable, and then we want to call that whatever that result is .printlist and see what we get. So that's kind of just setting us up, and now we can go to our problem. So what do we want to do here? We're going to want to be reversing things, right? So let's set up all of our variables just like last week. So we need a current, and we can initialize that to head, and then we need a previous, and we can initialize that to null. And then we're going to loop through our linked list, right? So this is going to be loop through the parent linked list. And what we want to do is we want to do a few things. We know we need to capture this thing called last node of previous part, right? We also want to capture the last node of sublist, right? We want to reverse k nodes, so that will be, let's say we're just starting, and the first thing we want to do is we want to reverse a sublist of size k. So we want to reverse those k nodes there. We want to reconnect the reversed sublist to the parent linked list. And then finally, we want to kind of continue to process another sublist of size k and not reverse them. So we could call that skipping, right? So let's say we want to skip the next k nodes. And then after we've done this reverse, reconnect, skip, we want to continue to loop back around and do it all again until there is no more current, because we've gone through our entire linked list. So I think some of the places to get tripped up in this algorithm are, where do we actually get those values, that last node of the previous part and the last node of our sublist? Where do we actually have access to those? So at first, when we, let's say, we can say const last node of previous part, I think we can just set that to previous. And what that will do is at first it will just be null, but after this while loop has completed, previous will actually be the last thing we've processed. So that will be our last node of our previous part. And we'll see how this goes. You guys can hold me to it, but we'll fill all of this scaffolding out, and we'll walk through it all and make sure that this actually works. And then for our last node of our sublist, that is going to be whatever our current node is, because at this stage, let's say we're starting at 1, and we're going to reverse 1 and 2. So that means we're going to have the first node process, which will be 1, it's going to end up being the tail of that sublist after we've reversed it. So that's where we can capture that last node of our sublist. We know that it's actually going to be the first node that we process of this sublist, if that makes any sense. And then finally, we're going to want to capture something called old next. And this is going to be a temporary value, and this is going to be a continuation, just like last week's algorithm, where as we're iterating, we need to somehow keep track of what was going to be next in the chain, because we're going to have to connect that when we do the reversal. If you don't remember what I'm saying, it should become clear to you as soon as I write this reversal code. So let's go into the actual reversal code. So this should look like, the same as last time. However, we do want to keep track of, we only want to reverse k nodes, right? So we can set up an I equal to 0, and we're going to increment that until I is greater than k, and then we'll stop. So this is going to be while there's a current and I is less than k. So that's going to be how we keep track of the bounds of our sublist. We are going to set our old next equal to the current dot next, because eventually we're going to want to reconnect these things. We're going to want to set our current next equal to previous. So in this case, we're setting our current dot next, our current being 1. So that's dot next will be previous, which is null, because we haven't sorted through anything yet. And that makes sense, because it's now going to be at the 1 is going to, so it's going to be at the, instead of being at the start of the list, it will now be at the end of the list. So as a tail, it has nothing after it. We are going to set previous equal to current, because now that the current is the last thing that we've processed. And we are also going to set our current equal to that old next. So that is what is responsible for pushing the while loop forward. So let's walk through it with our example. So we have current, which is equal to 1. Our old next is going to be equal to current dot next, so that's going to be 2. Our current dot next, which will be 1, is now going to be null. Our previous is now going to be 1 because we just processed it, and our new current is going to be the old next, which was 2. So now we have our 1 pointed at null, and we are going to loop back around, and we are going to now have our old next be our current dot next. So old next is now going to be 3. Our current dot next is going to be previous. So previous is 1. 2 dot next is now going to be 1. Our previous is going to be current. So the last thing we looked at is going to be that 2. And our current is going to be the old next, which is now 3. So, we can just write that down here. So let's say our, previous is now equal to 2. What else? Current is equal to 3, right? And old next is also equal to 3. So hopefully that kind of orients everybody just for the time being. So what do we have to do now? So now we have a little sublist, and it's a 2 pointed to a 1 pointed to a nothing. And we want to reattach the 2-1 sublist back to the parent chain. So we want 1 to now be attached to 3. So how do we do that? So we want to, that's down here, reconnect the reverse sublist to the parent linked list. So here we want to connect the sublist to the previous part. So remember, in this case, we have no previous part because we're at the very beginning. So we can say if the last node of the previous part exists, which in our case it does not, right? Because our last node of the previous part is null. So we can just set, what does that mean? We can set our last node of the previous part, or hold on one second. So we don't have that. So let's hold off on filling that out. because we're going to end up in here at first. So if we don't have a last node of the previous part, what does that mean? That means that we want to define our new head equal to previous. Now previous is 2. So why are we defining our head as previous? Because now, because we reversed 1 and 2, so now we have 2 and 1, 2 is now our head of our, managing linked list. And that's actually only going to happen one time. And the one time it's going to happen is when we don't have a last node of the previous part because we're at the beginning of the chain. I hope this is making sense to everybody. Okay, so we want to do that, right? And what happens, I guess, why don't we wait to fill this out until we're there in the code. So we'll get there. So just hang tight for 1 second. So what else do we have to do? We have to connect the sublist to the next part, right? So we still have a floating sublist at the moment because just because we've set the head to now be 2, 1 is still not connected to anything else. So what do we do here? We say our last node of the sublist, which is going to be 1, right? I'm going to just continue to take some notes here. So this is equal to null. And this last node of the sublist we had set to be equal to 1, right? Because we set it to the current before we started this whole process. So we want to set the 1.next equal to current, which is 3. And that's how we reconnect the sublist back into the parent list. So hopefully that was clear. Again, to do, we'll fill that out when we get there. And now we've reversed a sublist. The next thing we want to do is just skip the next k nodes. So this is going to look very similar to what we have above. We're going to have an I equal to 0. We're going to have a while of current, and I is less than k. And we're not reversing anything, but we still do want to move that previous marker along because we are going to want to set, we want to keep track of the last thing processed because it's going to become our next last node of the previous part. That's going to be the last node process before we start to reverse things again. So what do we want to do here? We want to say previous is now equal to current. Current is now equal to current.next and I++. And so that should, again, the only purpose of this is to really continue to move along that previous. And then we are at the end. So we go back to the top, and I'm already noticing a bug, so let's fix that before we get too far ahead of ourselves. Of course, to do this while current and I is less than k, we have to iterate and increment I. So I did not do that in this first loop. So that would run on forever and that would make me sad. So let's just add in that I++ here, just so with each iteration of this while loop, we are only iterating as many as k times. So hopefully that didn't confuse anybody further, but I saw that and wanted to fix it immediately. So we're back at the top of our loop, and we now have our previous set from here. We have our previous is now set to 4. That's our last thing that we've processed. So let's update our notes here. Our previous is set to 4. That means our last node of our previous part is set to 4. Our last node of our sublist is current. That means our current is now 5. Right? Because here we set previous equal to 4, and then we set our current to current.next. 4's .next would have been 5, so our current is 5. Where am I? Here I am. Our last node of our sublist becomes 5. And our old next becomes null again. And we repeat. So we go through, we reverse our nodes. Our old next is equal to current.next, so that will be 6. Our current.next is now equal to previous, so our previous is 4. Our current.next then gets set to 4. It doesn't actually matter what this is set to because we are going to reset these to reinsert it back into our parent chain. So just, hold off for a second. Our previous becomes equal to current, so that becomes 5. And our current becomes our old next, so that becomes 6. And I believe these stay the same. And again, we do the same thing again. Our old next is now going to be 7. Our current dot next becomes previous, so that means 6's next is now 5. That's the actual reversal, so now 6 points to 5 rather than 5 pointing to 6. Our previous becomes our new current, so our previous becomes 6. And our current becomes our old next, which is 7. And these two stay the same, and we have reached K at that point, so we stop iterating. So let's do this part. So what do we have to do to connect? We now have our sublist, which is 6 pointed to a 5. How do we connect 4 and 6? So as you can see, it's pretty simple because our last node of our previous part is 4, and our current is, our previous, the last thing we've processed is now the new head of our sublist, which will be previous. So we can just simply set last node of previous part is now equal to, its next is now equal to previous. So if our last node of the previous part is 4, we're now setting 4.next equal to 6. 6 points to 5 because we reverse things, and now we need to set 5 equal to 7, right? And we do that here. So if our last node of our sublist is 5, its next is now current, which is 7, and we have successfully reconnected our reversed sublist back into our main chain. And then we skip the K nodes, etc., etc. And that might be the entire algorithm, I think. So finally, at the end of all of this, let's return head, which remember is going to be our new head, the result of reversing that first initial sublist. And let's see what we get here if we call this. So we have our first printle of, printle is not a word, our first linked list that we print out, 1, 2, 3, 4, 5, 6, 7, 8. And then here we have, I'm highlighting to make it easier. So let's see, we've reversed the first 2 because K is equal to 2. So we have 2, 1, 3, 4 not reversed, 6, 5 reversed, 7, 8 not reversed. So that's the whole algorithm. I think the points to really, really make sure you understand is where and why, I'll get rid of these notes, where and why we keep track of these two things, the last node of the previous part and the last node of the sublist, and also keeping track of our previous, which we move along the entire time we go through the linked list. And yeah, this is definitely, a little bit of a doozy. I think that there are a few things to really know backwards and forwards before you start this sort of problem, such as the reversal of a linked list. I think understanding this piece is key. And then, like I said, understanding the reattachment of the sublist, and then understanding how we go about skipping those next K nodes for the ones that we are not reversing. And that's it. Go over this with a debugger, a pen and paper, keeping track with notes just like I did to watch how the algorithm progresses. But that's basically it for our linked list problem for this week. That's a wrap, everybody, on our medium difficulty problem with linked list reversals. Join me next time where we'll do an even harder problem than this, and we will all continue to better our interviewing skills, understanding how all these algorithms work, so we can better apply all of these tools that we're learning to any problem asked to us. Hope everybody had a really nice Labor Day weekend, getting back into the groove of things with the school year starting. And yeah, I'll see you all in the next one. Bye.